This is Algebra 2 at Trig, Unit 1C.1a. We are factoring today, but we're going to be doing a's greater than 1. Now x squared has a coefficient other than 1. Notice here that the leading coefficient is a 10, is a 6, is a negative 6. It's other than 1. Therefore, we will have to take that into account when we're factoring. We can't ignore it and just do it like we used to treat it with a 1. Remember that the factored form should be equivalent to the standard form. When we factor, your final answer has to be able to create the standard form. One way you could verify this, if you had a graphing calculator, you could type in your standard form and look at your table. You could type in your factored form and look at the table, and they would be the exact same table, the exact same equation. They just look different because they're in a different form. So let's try this. We're going to look at this factoring question that has an a value greater than 1. So when we make our table, we've talked about this before, I'm going to use factor by grouping as our method here. For the majority of these, we're going to do factor by grouping today. 10 times negative 3 is negative 30. You have to use the 10 in your calculation. That adds to be the b value, which is the negative 1. If you know the two numbers that multiply to be negative 30, that add to be negative 1, you can put them in the table right now. But let's just say for a moment, I get confused with my numbers, so let's think about this. What multiplies to be a negative? We know the signs have to be different. To multiply to be a negative, you have to have different signs. And to add to be a negative, you know your larger number has to be negative. We're going to do that every time. So this is going to be 1 and negative 30, 2 and negative 15, 3 and negative 10, 4 doesn't go into 30, 5 and negative 6. Those are the only ways to multiply to be 30. There's an infinite number of ways to add to be negative 1, so that's why we don't work on that column. We only work on the multiples, because that's limited. Now we're going to add these together to see what do we get when we add our two values together. And of course, 5 and negative 6 multiplies to be negative 30, and it adds to be negative 1. So we made our table just like we did yesterday. But we have to do more than just take the 5 and the 6 and put them in the parentheses. So I'm going to bring down my 10x squared. What makes the value of negative 1x? What two numbers should we use that makes the value of negative 1x? The 5 and the negative 6 add together to be negative 1x. So we're going to say 5x minus 6x. The order of those two do not matter. You'll get the same answer. Your work will be a teeny bit different, but the same answer. And then negative 3. So look what I did. I put the 10 with the x squared. I put the negative 3 into the problem. And I just made my 1x look like my 5x minus 6x. So now since we put our two terms in the middle of our 10 and our 3, we're now going to do the factor by grouping part. So we circle the two groups. What can factor out of my first group? What number goes into 10 and into 5? 5 does. Because they both have x's in them, I can factor out a 5x. 5 times what? 5x times what makes 10x squared? 2x. 5 times what makes a positive 5x? It's got to be a positive 1. bring down this exact sign. Bring down the negative. Now, what can you factor out of 6 and 3? Is it going to be an x? No, because they don't both have x's. They will never both have x's. So if I do the negative 3 times what makes negative 6x? 2x makes negative 6x. Negative 3 times what makes negative 3? Positive 1. A lot of people make a mistake and they call this negative because that's a negative 3. But your negative, don't forget, is part of the question already. So negative 3 times a positive 1 makes a negative 3. So from this part, if we were to take those two numbers and factor out those two values, what were exactly the same, right? I guess we didn't talk about that. What do we notice that's in there? They are exactly the same. 2x plus 1, 2x plus 1. They have to be exactly the same. So now what I'm going to do is factor out those two values. I'm going to pull them out. So all I'm going to do is kind of like shade them for a moment because we're going to pull them out. So what's left over? What do you have if you take out what's the same in both groups? You have a 5x and a minus 3. 5x and a minus 3. That number and that number. And then what we factored out was your 2x plus 1. And there it is. You factored it. Let's try our next one. Do you see a GCF? Do you see a value in this one that can be pulled out of all three terms? So we do not have a GCF, so the numbers are kind of big, but we can handle it. We're going to do 6 times 10. That makes 60. That adds to be negative 19. Anybody know two numbers that multiply to be 60 and add to be 19? Okay, if it doesn't come to you, don't spend forever trying to figure it out. We know that to be a positive, the two signs have to be the same to multiply to be a positive. They have to be both be positive or they both have to be negative. Since we're adding to be a negative, we know that both numbers have to be negative. So we're going to use negative 1 and negative 60, negative 2 and negative 30. I'm just going through my multiples of 60. 1, then divided by 2, then divided by 3. How many times does 3 go into 60? 4. How many times does 4 go into 60? 15. Hey, wait a minute. Those two add up to be negative 19. If those two add up to be 19, we don't need to keep going. We already figured it out. If you knew it in the very beginning, you could just use it. You don't have to make the whole list. But if you're not sure, don't sit around and try to figure it out for too long. Just make your list and you'll find it. So we're going to take our 6x squared, our negative 19x, negative 4x, and our positive 10. So I put my, I said 19. I'm sorry. What number do I need here? It should be these two values. I got carried away. This needed to be 15. How did I know something was wrong? I knew that these needed to add to be 19. And 19 and 4 doesn't add to be 19. So that's different ways you can check your work to be sure you don't make a silly mistake. Now we're going to group our terms together. I put circles around my groups. Don't use parentheses, because that's a mathematical term that we use to represent other things. We don't use circles for anything else with math. Nothing else. Absolutely nothing. What can we factor out of 6 and 15? A 3x. What would be left inside? 3x times 2x. 3x times 5 is going to be a minus 5. Bring down your sign. I want you to start thinking about this. What can we factor out of 4x plus 10? Factor out of 2. It's never going to have an x because both terms don't have an x. You need to be observant to that. They never will on this second pairing. So, negative 2 times what makes negative 4x? 2x. Negative 2 times what makes positive 10? Negative 5. What do you notice about your two parentheses? Exactly the same. That means you didn't factor out the wrong term. That helps you be able to check your answers. All right? If those are not the same, then you factored out the wrong number. And that happens. You just got to go back and clean it up. So our final answer is 3x minus 2, and the two terms that are the same are 2x minus 5. We can test this to see if it works by doing FOIL. 6x squared minus 15x minus 4x and positive 10. And when we collect our like terms, we get what we started with. So you can always check your work to see if your answer is accurate. You never have to not be confident. All right, what do we notice with 3? It has a greatest common factor. What also catches my attention is it has a negative in front. You never want a negative with your square. So I'm going to factor that negative out. I notice that they're all even numbers, so I'm going to factor a 2 out. That's going to leave me a 3x squared, a negative x, and a negative 4. So I make my table. I do 3 times 4, 3 times negative 4, to give me negative 12. That adds to be negative 1. Making my same table like I usually do. I'm using my smaller version of the equation because I factored out a 2. So I know it's negative, so my two signs are different. It's adding to be a negative, so my larger number has to be negative. So 1 and negative 12, 2 and negative 6, 3 and negative 4. Those are the only ways to multiply to be 12. So I know my answer is 3 and negative 4. Unfortunately, you cannot just drop that into the parentheses. You have to do the full calculation. You have to do the full factor by grouping. I bring over my 3, so it's 3x. I bring over my negative 4, so it's negative 4x, because those two add together to be negative 1. And I bring down my negative 4. We group the front two, and we group the back two. Factor out what you can out of the first group. What would we have left? X plus 1. Bring down your sign. Factor out what you can. What number divides into 4x? What number divides into 4? Well, 4 does. And that would leave me an x and a positive 1. Lots of people make a mistake there, and they call that negative 1. But don't forget, it's negative 4 times a positive 1 that makes it become a negative 4. You got to be able to distribute in to make what your original was. And now I'm done. I bring down my 3 and my 4, 3x minus 4, and x plus 1. You're welcome to FOIL that to check it to see if it's right. Now, for you to get your original answer, you need to remember your negative 2. You have to have the negative 2 for this to be accurate. Have to. Okay, we're going to slide down here for now. Okay, we learned our special patterns yesterday, but we're going to just practice them again with numbers that are a little larger. This is called the difference of two squares. That means you have a perfect square minus a perfect square. Your result will always be a minus b, a plus b, or the opposite order of that. Doesn't matter how you write it. So let's try that out. Let's come on down. What makes 4x squared? So what you're asking yourself is, can you take the square root of 4x squared? The answer is yes, that's 2x. Can you take the square root of 9? Is 9 a perfect square? Yes, you can. It's 3. So if you can take the square root of both of those terms, and it's a minus in between, then the magic pattern is 2x minus 3, 2x plus 3. And if you take time to FOIL that together, you'll see that those middle terms will cross out, and you'll be left with what you started with, 4x squared minus 9. You can always check your work. Letter B. Now there's a couple issues that happen here at letter B. Let's just get carried away and say that we're going to take the square root of 9x squared. That's 3x. Take the square root of 36. That's 6. We're doing a great job. We know this is the difference of two things that are being squared. That's square rootable. That's square rootable. So I'm going to write 3x minus 6 and 3x plus 6. But I don't get full credit for this. Why doesn't this receive full credit? It can still be factored. That has a factor that can come out of it. This has a factor that can come out of it. So I have a 3 I can pull out, and I have another 3 that I can pull out. So I'm going to have an x minus 2 and an x plus 2 in the parentheses. So my best answer is 9, x minus 2, x plus 2. You could have done that from the very beginning here. Pulled out your 9, and you could have helped yourself get through it a lot quicker. All right, last two. Notice how these are a little bit different. These aren't binomials, these are trinomials. I can still take the square root of the first term. I can still take the square root of the last term. But my middle term is not 0. So if it's 2 times those two values multiplied together, then I have a plus b and a plus b, which is going to be a plus b squared. So the question is, can I take the square root? Yes. Can I take the square root? Yes. And is my middle term 2 times those two values multiplied together, the a and the b? 2 times 2 times x is 4x. So yes, it is. So my answer, my work is done. 2x plus 1 quantity squared. You don't have to do the 4 times 1, make a table, what multiplies to be 4 and adds to be 4, and then factor by grouping to make it work out. You got it right there. What do we see here with this last one? We have a GCF we got to pull out. Then, can we take the square root? 3x. Can we take the square root? 1. If you multiply these two numbers together, you can take the square root, you can take the square root, those multiplies together to be 3 times 2 is 6. It is twice as big. So we have factored it off with our GCF in front. So now let's slide up here and work through these last 3 questions. We jumped over those for a moment. Okay, I noticed that my trinomial, my quadratic, has a leading coefficient. So to factor that's a little more challenging. So we're going to take our A times our C. Adds to be 1. I know that's going to be 2, negative 2, and positive 3. That multiplies to be negative 6. That adds to be 1. So I'm going to put that value in the middle of my equation, in between my 3x squared and my minus 2. I circle my 2 groups, factor out my x. So x times 3x, x times 2, bring down your sign. What can you factor out of this? Nothing really. So we have to factor something. You have to have a place value hold. It's got to be a 1. So 1 times what? 1 times 3x. 1 times what? 1 times negative 2. That would distribute to make this. What's inside the parentheses is exactly the same. So my answer is x plus 1, 3x minus 2. You could FOIL that to check it. Ten times negative 2, that adds to be 1. If you know what the answer is, adds to be negative 1 means the larger number has to be negative. And they're 1 apart. And they multiply to be 20. You can make your long list, but if you know the numbers, just go to the numbers. So we're going to have 10x squared minus 4x plus 5x minus 2. Circle your group, factor out what you can. Oh, they're both even, so it's going to be a 2x gets factored out. So 2x times what makes 10x squared? It's got to be a 5x. 2 times 5 is 10. X times x is x squared. 2 times 2 is 4 times x, 4x. Bring down my sign. All I have a place value is 1 because nothing factors out of that. So that's 5x minus 2. So this is 2x plus 1 and 5x minus 2. Last one. There's no GCF. It almost looks like there is, but there's no GCF in all 3 of them. So we're going to do 9 times 8 is 72. That adds to be 18. I know that I have a positive 72. So my 2 signs have to both be positive or they have to both be negative. Since it's adding to be a positive, I know that they both have to be positive. So 1 times 72, 2 times 36, 3 times 24. 3 goes into 7 twice with 1 left over. 3 goes into 12 4 times. 4 times 18. 5 doesn't go into 72. 6 goes into 7 once with 1 left over. That's 12. So 6 times 12 is 72. and that adds to be 18. I found it. So I have my 9x squared, my plus 6x, my plus 12x, and my 8. Group my two sets together, factor out what I can. That leaves me with the 3x plus 2 and a plus. What can I factor out of 12 and 8? Going to be a 4, not 4x. There's not an x in both of them. 4 times what makes 12? 4 times 3x. 4 times what makes 8? 4 times 2. The parentheses are exactly the same. So I know I'm done with 3x plus 4 and my common parentheses, which is 3x plus 2. To fill the notes out completely, we were doing our rule down here that this was a squared plus 2ab plus b squared. If you have that pattern like we did here, we were able to take the square root of the first term and square root of the second term, and that product was half of the middle term, or they had to be multiplied by 2 to make the middle term. You can just take your a and your b and square it. Well, if you have a minus, we didn't have an example like that here, but if you have a minus there, it's going to be a minus b and a minus b, otherwise known as a minus b squared. That would be your shortcut to reaching this factoring without doing the full table and grouping.